So what we have done, guys, yesterday we have covered this part. So yesterday we have seen that how to configure the next hop exit interface plus the next hop plus exit interface. And then, we have seen that what are the major difference between sorry, between the static route with the next hop and a static route with the exit interface, right? So we have covered that, this one is a better solution. If you go with the next hop is a better solution as compared to the exit interface, because in the exit interface, what happened? You must need to have a proxy ARP. If the proxy ARP is not enabled, then you cannot make a static route with the help of exit interface, right? So this solution is not good. This solution is better than this one, right? But again, if you compare with this solution now, the first solution is good, right? But the problem with the first solution is what? It is doing the static recursive lookup. So every time if the router is receiving just a 1000 packet, take example, if the router is just receiving the 1000 packet, we have a source will be x dot x dot x dot x dot x, distance will be 1.1.1.1. Just a 1000 packet as the ping 1.1.1.1, repeat is a 1000. Then what happened? The router has to perform the lookup is a 2000 times, right? That's not good for the router CPU perspective, right? So to avoid this problem, right, what we have introduced, we have introduced the combination of exit plus next hop, this one. The best part, right? The best part of this two guys is what? The best part of this guy is what? If you're going to use this one, the first of all, understand the concept. If I talk about the ARC perspective, right? If I talk about the ARC perspective, so it only has a one entry. It only has a one entry in the ARC table for all the route. So take example, if you have 100 plus IP addresses, or maybe we can call as 100 plus IP, thousands of the route plus, right? For all this guy, you only have a single ARP entry. That's a one beauty part, right? Now, if I talk about the CPU perspective, right? If I talk about the CPU perspective, in this case, what happened? Right? It is not going to perform the recursive lookup. The reason is that why this guy was doing the recursive lookup, because this guy doesn't know what is my exit interface. So if I'm already put the exit interface over there, so there's no need to do the recursive lookup. That's a beauty part over there. No need to do the recursive lookup. That's a beauty part of this guy. So if you're going to use the combination of, right, if you're going to use the combination of these two guys, right, then it's a better solution. Now, which one we are using in the production network? See, in the production network, what happened? You can use either you can go with this one, or either you can go with this one. Then what is the need of this command? See, do you know what happened? Static route, it's not a new technology. First of all, it was a technology in the 90s time. On that time, what happened, right? We had a serial link cable between the router to. It's not like a serial link, we are not using it. Again, I'm repeating it. It doesn't mean that we are not using the serial link. We still using the serial link. Even I have seen in the production network, right? I'm telling you, the 20 days back, I was troubleshooting one of the network, right? And I found that the company, I'm not going to use the company name, but I found the company was using the serial link. So it doesn't mean that serial link is not used. So on the serial, if you have a serial link, right? If you have a serial link, then this solution is good solution, right? Because in this solution, what happened, right? On the serial link, we don't have a MAC concept. We don't have any MAC address on the serial link. So if you don't have any MAC address, so there will be no ARP concept over here, right? So you can go with this solution if you have a serial link. But if you have an Ethernet technology, right? The fast Ethernet, gig Ethernet, then you have to go with this one or this one. So this one is always the best solution, but once the people doesn't have a knowledge about this thing, right? At the label of this thing and this thing, then normally people used to configure this part. But the best solution is what? This one. So let me show you. If you want to configure this guy, then you will only have a one ARP entry, and there is no need of proxy ARP even in this case. Because eventually what happened for this case, what happened? ARP will be generated. ARP will be generated for next hop IP. So that's a beauty part of this guy. So have a look. So what I can do that I show IP interface brief. If you see, I already have a 12.1 for this particular interface. And on the router number 2, if you see show IP interface brief, I have a huge loopback. Let's do on the router number 1. If you put the command show IP route is static, I don't have any route over there. So let's configure this guy. I already have a notepad. Okay, so I'll reconfigure this one. So now static it out with static dot exit interface with next hop. So I can say the IP route 1.0.0.0. If you see the beauty part, right? And I said the 0/0, next hop will be 12.2. Okay. Okay, done, right? So we have a 2, this guy, we have 3, this guy, we have 4, this guy, we have 5, this guy, 6, 7, 8, 9, and last one is 10. Copy and paste it. Now have a look over here, understand the concept, right? If I'm gonna make a ping debug ARP, if you see, if I'm gonna make a ping 1.1.1.1, so I will generate the ARP request for the next hop IP, not for the destination one. That's a beauty part. So if you're gonna use this combination, in this combination, what happened? Router generate ARP request only for the next hop. So try to understand, even if I'm gonna, which is by default, the proxy ARP is enabled, right? If you see, so IP interface 0/0 include proxy. By default, proxy ARP is enabled, right? So even if I'm gonna disable the proxy ARP, it doesn't matter. If I'm gonna disable this guy, it doesn't matter. No IP proxy ARP. I can still send the traffic. I can send the ping, also the ping 1.1.1, also the ping 2.2.2.2. In this case, I'm not going to generate the ARP request because I already have a ARP entry for what? I already have a ARP entry for the 12.2, right? If I already have ARP entry for the 12.2, no need to generate the ARP request for the 2.2.2.2. So ping, working fine, 3.3.3.3, 4.4.4.4. You can see that the proxy ARP is disabled right now. I can still send the traffic. So there is no problem if you're going to use the combination of exit plus next hop 6.6.6.6. And in this case, we are not doing the recursive lookup. All my traffic is directly hitting to the what? Interface to the next hop. All ping. If you see the show IP route, what you can see that if any packet is coming for the any network 1.0.0.0, I need to forward the packet to the 2.2 from which interface 0/0. So I have all information. I have all information in my routing table. So there is no issue. The good thing about if you see this guy is what? Show IP Ceph 1.0.0.0.0. And what you can find it, there is no recursive keyword over here. If you see in the previous case, we had a recursive keyword, right? But now we don't have a recursive keyword. So if you don't have a recursive keyword, I don't have a recursive lookup over here. Now you got it. So what is the difference between all these three commands? The first, second, and third. So in a production, always you are going to use this command because this is the good one. But if the people doesn't have a knowledge, I have seen the people who doesn't know the depth level of the concept, right? About the ARP and CPU perspective. So normally people are used to configure this command as well. But by mistakenly, if you're going to configure this guy, the exit interface, make sure that your proxy app should be enabled. And now you may have a question, hey, law, by default, proxy app is enabled. There's no issue. Okay, that's not a big deal, but proxy app has a lots of disadvantage. Service provider never allow itself to enable the proxy app. There's a many reasons. When you go for the higher level, then you will understand the things. It's not recommendation to enable the proxy app, because if you're gonna enable the proxy app, any attack would be happen in your network. Understood? Questions, guys? No? Okay, let's move. Now take example, what happened? If you check my routing table size, if I go to router number 1, I say the show IP route summary, right? What you can find that, you can see I have a total is 11 routes I have. The static is 10 that I have configured, right? And the one is connected route. So total is 11. What is the size of this routing table right now, router 1, consuming it? So the total size of routing table is consuming the 1408 bytes, right? So total size of routing table is what? 1408 bytes. You can assume like this way, each route, right? Each route is almost consuming 110 bytes to the 120 bytes memory. A single route is going to consume this amount of memory. Now, right now you think that it's a good thing. That's fine. Right? But what happened if your router doesn't have that amount of memory? For example, if you're into configure the 2000 static route, and this 2000 static route is going to consume the almost 20,000 bytes of memory, right? And if you don't have that amount of memory in your routing table, then you could not able to install those route. And if you could not able to install those route in the routing table, then what happened? Could you ping this guy? No, you cannot. Try to understand, you have a phone, right? And in this phone, you only have a storage of what? 5 numbers. Only you can store the 5 numbers of contact. So you have already installed the A, you have already installed the B, you C, D. You have already saved all this number in your phone book. Can I save the name G over there? No, I cannot it. So can I make a call to the G? Normally, you could not, because you don't have a number of G right now in your phone book. Same thing, if you don't have a space in your routing table, if you don't have a space in your router memory, how could I install all the routes in my routing table? That's the one problem. Second problem is what? One problem is a memory problem. Second problem is what? Do you have any idea how many routes are present on the service provider network? Maybe the 10K, maybe the 20K, or maybe the 5K, or maybe the 1K. Is it possible that all this 10K, 20K, 1K routes you can configure manually on the router number 1? Is it possible that you can configure all this 10K route manually on the router number? Okay, this is just a simple topology, guys, a very basic example that I gave you. But take example, if you have a very big network where you have a 5 to 6 routers over there, is it possible that you can configure all this 10 to 20K routes manually on the each box? No. So to avoid this problem, what we have come with the concept, we have come with the concept is known as a default route. Default route is also known as a less desirable route. You will get to know that what is the meaning of less desirable route in the EIGRP class, maybe in the Tuesday or Wednesday. What is the meaning of less desirable? The default route is known as a less desirable route. Understand the concept like this way, right? If you don't have any route in your routing table, for example, if any packet, take example right now, you have this route in a routing table right now, okay? And if I want to make a ping 192.168.1.2 right now, understand the concept. Can I ping the 1 or 2 right now? So when this packet comes to the router number 1, It look up the routing table. Hey, do I know about the 1 or 2? No, I don't know about the 1 or 2. So in that case, what happened? It will forward the packet based on the default route. So if the route is not matching with the any specific one, if this guy is not matching with the any specific one, then it will match with the default route. So that's the beauty of the default route is what? If any packet comes to me, right, I will forward the packet to my next hop to LR2. Any packet, doesn't matter what destination we have. I'm gonna match all the route. I'm gonna match all the route. So let's remove all this static route right now from the router on the router one. And what I can do that, let me do one thing. I'll say copy. And I'll say no. Copy. Okay. And let's put this command on the router one. So all the route has been removed. You can see that I don't have any route. Right? Now what I can do that, I'll just give the one default route. IP root 0.0.0. You have a 3 ways to configure the default route. Same like that, we have configured the static route. Whenever router receive the packet, it look up the routing table. If the router does not able to find the specific route in the routing table, then router forward the packet based on default. So simply 3 ways we have. So one way is this, you can configure like this way that we have seen. Next hop like this way. Second way we have like this way. And third way we have like this way. So I'll just come and configure this way right now. All done. Copy and paste. Now, if you see, do I have any route in my routing table apart from the default route?
No, sir.
No, I can send the traffic to the anybody. So when I say the ping no 1.1.1, so when the router will receive the packet that has a source will be could be anything x dot x dot x dot x dot x. Destination is 1.1.1.1, right? When this packet comes to router 1.1, router will say, hey, do I have a 1.1.1 in my routing table? Let me check my routing table. So IP root 1.1.1. No, I don't have any route in my routing table for the 1.1. So if you don't have a 1.1.1, then what happened? It will go for the less specific route. And that's a default route. And based on that, he will forward the packet to the 2L2 via this interface. So now if I'm gonna ping 1.1.1.1, working. If I'm gonna ping 2.2, I don't have a route in my routing table, but still I can send the traffic 3.3.3.3. I can ping it 50505. I don't have this route mine, but I can send the traffic. That's a beauty of the default route. So you can just send the traffic to the any network, right? Now, can I send the traffic to 11.11.11? I can't. The reason? Because 11.11.11 is not present in my topology, right? Who will give the reply? If I'm going to call the 1.1 will give the reply. If I call to the 2.2 will give the reply because 2.2 is present. If I call the 10.10.10.10, he will give the reply. But if I'm going to call the 11.11.11.11, who will give the reply? No one is sitting over there. So this packet will be dropped. Just based on the thing. So if you compare now, if you just have a look, the beauty of the routing table size. Let me show you this difference. And now have a look. So IP root summary. Can you see the difference now? Previously, it was a 408 bytes of memory. Now we have just 256. I just have a, previously we had a 11 route and now we just have a 2 route.
Question.
That's a part of, that's a use case of the default route, guys.
Question. So that default route, can it be set to some other IP too?
What do you mean? Sorry, what do you mean by some other IP?
No, like, I mean, can any IP be configured as a default route if need be?
No,
or...
the default route always should be in the 0.0.0.0.0.
Okay, gotcha. Okay, that's the feature.
That's
Okay.
So this 0.0.0.0/0, it's called as a default route. It's a reserved route.
Understood. Thank you.
Now the next part is what?
Hello.
Yeah, go ahead.
The default means passing the all route.
Send the all traffic via that route. So it doesn't matter what
Okay,
IP
sir.
address you have. I can send the traffic to the every network. So
Yes,
I just
sir.
have one route, and based on that, I can send the traffic to the 1.1, to the 2, to the 3.3, anything.
But only if there is no route specified for that particular packet,
Exactly.
correct?
And that's a beautiful question. So take example, you have a static 1.0.0.0/8, and at the same time you have a default route. Okay. Now the next stop is a 2LR2. Next stop is a 2LR2. Now take example, if the packet is coming that has a source will be x.x.x.x, destination is 2.2.2.2. So which one I'm gonna pick? This one or this one? If this packet is coming to the router, which one router will pick? Default route or this one?
Static.
Default route, right? But take example, if the packet is coming like the x.x.x.x and 1.1.1, then which one we will pick? You will pick this one because it's a more specific route. This one is a more specific because it's gonna match this person. If it is not matched, then I will use the default route. Default route is always a less desirable route. It only comes in the picture when you have done, when the router is not able to match the route. Understood?
Got it.
Great. Now, the next one we have is what? Take example, we have router number 1, right? And we have router number 2 as well. There's a link between this guy, and thus I have a, some subnet behind the 2.2.2.2.2 right now. And the 0/0 we have, 0/0 we have. And the subnet that I'm going to use is called the 12.1 and the 10.1.12.0/24. And this guy's a 12.2. So right now, the user sitting behind this guy, they are communicating with this person 2.2.2 awesomely, right? There's no issue. This guy is able to send the traffic to this guy via this particular link, right? We are all exchanging the traffic through this particular link. But what happened if this link goes down? That's called as a what? This is called as a single link failure. Remember spanning tree topology?
Yes, sir.
Single link failure.
Yes, sir. Yes.
So to avoid this problem, what I can do that, I'll put the backup link over there, right? I'll say, hey, let me add another link over there. I'll say the 0/1 now. And this is 0/1. So now this link that I've used, this is the 13.1, stand.1.13.0/24. This is the 13.2. So this is the link that I use for the backup purpose. So I can say that, hey, this my link is a 10 Mbps link and this my link is a 2 Mbps link. But due to the problem comes over here. So when I give the static route, understand the concept on the router number 1, I said the IP route 2.0.0.0, right? Subnet mask 0/0, or make just let's make the simple one 2LR2, IP route 2.0.0.0. Then what? Next will be 13.3. Sorry, 13.2 now. So I have to give the route through this one, and I have to give the route through this one, right? Path and route, same difference. Same thing, sort of. So this one, right? So now we have a static 2.0.0.0. What you will find that you have a 1/0. And the next stop will be what? It's 2LR2. And same way, you have a next stop will be what? 13.2. The problem is what? Understand the concept. I have defined the route for the 2.0 network from this way and this way as well as why, because this is my primary link, the 10 Mbps is my primary link, and this is my secondary link. But when I put this command, what happened on the router side? When I put this command on the router side, what happened? The router is going to install both the routing and routing table. Router is going to install both the routing and routing table. It means that whenever the router will receive the packet, take example, we have a source will be, destination is, right? So whenever the router will receive the packet, what router will do that? It will do the load balancing. Load balancing is what? I can share my traffic from this way and this way as well as. So 50% traffic will go via this way and 50% traffic will go via this way. Now, what do you think, guys? Is it a good way to send the traffic? The 50% from the above link and 50 from
No.
Why?
No, sir.
Why?
Because then the 10 Mbps would be underutilized, and to the 2 Mbps line is too small for that 50% traffic.
Okay, let me tell you one thing. Okay, good explanation, but I can still utilize the 2 Mbps link, right? In this case, I don't see any problem. You just underutilized, right? Let me tell you. All my take example, my 70% traffic will go via this way. Because it's a faster link, right? So 70% packet will go via this way, 30% will go via this way. So I can utilize this link as well, right?
Right.
The problem comes in the picture when you have a UDP-based traffic. UDP-based traffic, if I talk about the voice traffic or the video traffic, like watching the match online, Netflix, all this traffic, the voice and video traffic, right? UDP-based traffic. UDP-based traffic cannot be retransmitted. Cannot be retransmitted. So normally what happens, even if you have a voice traffic, so take example, if the message is hello, then what happened? I can send my data from this side as a hello, and O will go via this way. What the router 2 will listen over there. So first he will receive the packet hello, then he will receive the packet O over there. What he will understand? 0 hello or O hello. So it's depend on the requirement. Load balancing is, load balancing is a good solution, but in not every cases, right? We have seen the Ether channel, right? In Ether channel, we did the load balancing. It was a good thing, right? But in not every scenario, the load balancing is a good thing. Even not, I just give the example of the UDP base. The reason is that you guys are familiar with the voice and video, like watching the online match, right? That's a pure UDP-based traffic. Right now, we are doing this thing, right? It is called our Zoom call. It's a UDP-based traffic. It also has some issue with the TCP-based. in some scenario. I cannot explain you because you will not understand that label right now. But yeah, we have issues. So load balancing is not always a good solution. But the problem is that what? When I give the route, when I give the path, router is able to install both the route in my routing table. I'm installing the primary and secondary as well. Why I have introduced the primary and secondary? Because if my this link is up, all my traffic will so go by the primary link. If the primary goes down, then you need to send and receive the packet through the secondary one. If the secondary primary comes up, then you need to remove this packet from the secondary link and you need to push the packet on the primary link. So it will be there, right? This link will be there, but it will be not utilized, right? It will be not utilized if the primary is working fine. But the problem when I give the path, when I give the route, it's installing the both the route in my routing table. So to avoid this problem, we have came with the concept is called a floating static route. The name itself says the floating is what? The backup one, right? This backup path always will be floated. Always will be floated means what? It will be there, but it will never comes in the picture until or unless the primary goes not down. So it will be always in the floating mode. How I'm gonna make this guys in the floating mode? What I can do that, I'll just give the higher AD value. AD value is known as a administrative distance. Some different vendor like a Juniper, they call AD as a preference as well. It is a 8-bit number. You can start with 0 to 255. This AD value is a local to the router, or we can call as a iOS as well, operating system, because in a Cisco, we have a different AD values. In a Juniper, we have a different AD values. We have a Palo and Checkpoint, they have a different ADs values. So never confuse whenever you give the interview in the different vendors company, and if they're asking the question regarding to the AD values, just say that depend on the vendor, this AD will be changed. So I'm not pretty sure because what AD value you guys are using it. And you will be not pretty sure what AD value we are using it, because a network engineer cannot remember each and every AD values for each and every vendor. So AD is a local to the router and iOS, we can call it. So Juniper has a different one, Cisco has a different one. Lower is more preferred. Lower is more preferred. Each routing protocol has some AD value. For example, we have a connected route. For the connected route, the AD will be 0. For the static route, the AD will be 1. For the EIGRP, if I talk about, EIGRP has a 2 AD value. One is called as 90, and another is called as 170. So different protocol has a different AD values. Whenever I'm going to discuss the like EIGRP, OSPF, RIP protocol, then I'll let you know whatever the AD is value for those routing protocol. But the static has a 1, and that's why you can see that over there. So if you see
Question.
static route I have given over there, this guy has the AD value is 1 over there. Go ahead.
Question. And again, I think this might be for future topic, but before I forget, you said the AD value will be different depending on the vendor, correct? But would that also be applicable different for things like, for example, BGP or OSPF, which are standard?
Exactly. So BGP, let me show you that. Hold on. I'll show you.
And again, if this is for later on topic,
No,
that's
no,
fine.
no.
I can
just
wait.
need a 1 minute, man. Just need a 1 minute.
No, I'm just saying. I don't want to. Thank you.
So preference PR preference routing. So Juniper is saying the route preference we call as a AD value, administrative distance. So if you see for this guy is using the OSPF for the 10, OSPF SR preference SRR for the 10. ISS is using the 14, ISS level is a 15. RIP has 100, whereas if I'm gonna use the RIP protocol in the Cisco, it's 120, right? Different protocol. BGP has 170. We don't have 170. We have a 170 for the EGRP. What is the static route they are using it? The static route they are using it 5 over there. So what we are using the static route 1 over there. So it will be very depend on the vendor by vendor, right? So what I
Okay.
can do that, yeah, question.
Oh, no, I was just saying, okay, thank you.
I'll put the link in the chat box if you want to refer. Just talk on it. Right? So now, so this is the AD values that we have. Lower is always preferred, always. Okay, this is the one use case that I have shown in the low AD value, right? It means that based on the AD value, you can manipulate the path as well. So what I can do that default is 1. I'll put the over there, it's 2. You can use any AD value, but don't use which is reserved for the any other routing protocol, right? Which is reserved for the any other routing protocol. So I'll just using the 2 right now. 2 is also reserved. So I'll make sure I'm going to use the 11 is not reserved for the anyone. In Cisco is not reserved. So what happened? Lower is always preferred though. Then what happened? This will be not there in the routing table. So all my traffic will go either 12 or 2. If this link goes down, if the primary goes down, then what happened? If the primary goes down, then backup comes in the picture. Then this comes in the picture. If this goes down. If this comes up, take example, then what happened? It will be removed. Again, if this goes down, then what happened? It will down. This will be removed. And this comes in the picture. All my traffic will go by the backup path. So automatically this thing will be happen. Automatically this thing will be happen. So I can do that. I have a lab for this one. I don't want to disturb this lab. Loading static. Oh, okay. So 2 is above 1, 10 is bottom 1. I'll make sure this guys will be. Okay, all good. Now here we go. So I hope I must have IP configuration on data 1. Let me configure it, man. So I'll do this lab over here in the notepad so you can refer this configuration from the notepad as well. Apple 488 coding standing up. Data 1. EPS 0/0 IP is virtual.1/24. The above one is a 0/1, it's 13.1. 13.1. And here we go. And here we have no back on the random one. Interface 0/0. IP address will be 12.2 0/0. No shutdown interface 0/1. It should be 13.1, 13.2 we have. And I have one loop back, which is 8.8.8.8. I need to save this configuration. So in the global configuration mode, you need to put the DWR command. Copy and paste. Of the number two, if we check the first verification, I don't have, let me put this guy. All done. So now what I can do that, I'll just configure the floating starting out on the Arduino one. So first I'll show you the normal ways, right? And then I can call this guys a vola2. And I have called this guy string of two. So if I'm gonna put the command like this way, then what happened? Both will be there in the Arduino table. So if any packet comes to me, I will follow the packet from both the way. What I can do that? I'll simply change this guy. I'll put this guy as a IP root. Let me put this over like this. Maybe 11. So even if you put this command like this way, let me show you in the CLI. 13.2 should be the secondary one because it's a 2 Mbps link, right? And if you see, it's asking for the distance, AD value. And put this guy's 11. You can define up to the 255, 11. So now what happened? Do show IP root static. Do you see now the 11? Okay, let me remove the first this guy. Now do show IP root static. No, come on. Okay, now section IP root and I need to remove this guy. Now this one, this one. So now I have a simple configuration. So if you see, this guy's a normal, I have changed the ID value for this guy. So now if you check the routing table, all good to go. Perfect. So if the primary goes down, right? Let me down this guy as the interface 0/1, shut down. Then what happened? Do show IP root static. I mistakenly I said that 0/1, 0/0, shut down. It's gone. You see that? So once this link goes down, right? Backup comes in the picture. If I want to up this guy again, right, then what happened? Primary comes in the picture. If I want to shut down this guy again, then what happened? Primary goes off and secondary comes in the picture. If I'm going to again no shutdown, then what happened? Primary comes in the picture. So that's called the static floating static. So both will be not in a running config. You will see both will be there. So if you put the running config, so do so run. In the configuration, you have both configuration. In a configuration, you have both one. But in the routing table, only this comes in the picture. When the primary goes down, then this will be not there. Then this comes in the picture. That's called as a floating static router. Questions? And I'm done with the static router. You can ask any question from the static router.
Hello,
Yep.
sir. If sir, your scenario R1 and R2, sir. If one link is down, sir, could you repeat again, sir? I can't understood, sir.
So agar mera primary link down jayega na, if this primary link goes down, then secondary
Yes,
comes
sir.
in the picture.
Okay, sir.
That's the meaning of floating. And if primary is up, then secondary never comes in the picture.
Sir, how can we know the primary and primary link is down, sir?
वो तो तुझे ऐसे ही पता चलेगा. So not so CDP never. You can check from the SO IP interface brief.
Okay, okay. So IP interface. Okay, sir.
The port is shut. Ultimately, it will show it's down. Simple. Again,
But now, तेरा link if your link is down in the production network, right? Already you will get to know that. Don't worry.
yeah,
There will
when
be
the light is red, that
there will be
means
outage. So you
Yeah.
will get to know that from your manager.
everybody will be calling you. Don't worry about that.
Yeah, see,
Okay,
something
sir.
is happening in your network. Link goes down, route is not getting its packet is getting dropped. You will get to know that. Just a
No,
Manager,
I think maybe Saurav bhai got a little confused because he's seeing that both link as based on the image as like one link. Again, this is just my assumption.
okay.
So I would say Saurav bhai ki, when one of the link goes down, it is
Yes,
like
sir.
any other link, right? Any other network link. You will see the light on the router or the device that will go,
Red color.
show the indication. You will see message in the router or the switch log that the port has gone down. And as Mr. Sa said, when you do the interface, obviously your link won't work and you will check as to what is happening. And then as Nasir bhai pointed out, the port will be down. You will see it in the log. You will see it in the IP interface brief. So these are like if these are two separate links, right? But they're just acting as a as a
one link.
option,
Okay,
redundancy. That's all.
okay. Means written. Okay, sir.
सर मैं नहीं हूँ भाई, सर उधर बैठे हैं मुझे लगा
No
कि सिर्फ
issue.
आपका शायद क्वेश्चन में आपके इमेज की वजह से कंफ्यूजन है, तो मैं थोड़ा चाइम इन कर दिया और कुछ नहीं.
Okay, okay.
आप भी सारी हैं.
अरे साहब
अरे भाई.
नॉर्मल बट्टा बड़ा लोड मतलब थोड़ा.
Okay, clear, sir.
अभी BGP प्रोटोकॉल देख के आया हूँ लाइव एनवायरनमेंट में. वो जब
So we have done with the static route, guys. Now you guys tell me, you want to start the dynamic today or we'll start with the tomorrow? It's up to you guys.
start tomorrow.
Static route, then you have to prepare yourself with the static route. Okay, and then whatever the questions you have, you can ask me tomorrow, and then we'll do the dynamic routing.
But some reason the lectures are not showing up on the drive.
It's
All the
showing that.
photos.
How can you tell me it's not showing that? It's
I mean,
there.
I've been looking into